Hello and Assalamualaikum to everyone. My name is Nurul Atiqah AMIRA binti RIZUAN and I'm from Group 2. Today we will present about our assignment 2 in Instrument and Measurement in Oil and Gas. Our title is Enhancing Public Safety Through Fiber Optic Monitoring. And this is my team member. First is me, Nurul Atiqah AMIRA. Second is Muhammad FAIZ bin ZAINOL ABIDIN. Third is Muhammad HARITH JAZMI bin Muhammad JAMIL, and lastly is ABUBAKAR ABDULLAHI MANGA. So first, I will explain about introduction for this project. So in recent times, safety in pipeline system has become a major concern. So one tragic example is the gas pipeline explosion at Putrajaya, Subanjaya, which happened in April 2025. It injured over 150 people, damaged property, and forced more than 500 residents to evacuate. The incident was believed to be caused by a gas leak from an underground pipeline, made worse by nearby excavation and the lack of proper monitoring. So this situation highlights the urgent need for real-time advanced monitoring system. So that's why our project focus on using fiber optic sensing to detect early sign of leak, pressure change, or other risks before they become disaster. So there are three objectives for our project. First is to develop a fiber optic monitoring system that ensure better safety and early detection of issue in pipeline. Second, to integrate DAS and artificial intelligence for smart and accurate hazard detection. And lastly is to reduce environmental and operational risk by improving response time, preventive maintenance.
Hi, my name is Muhammad JAZMI bin Muhammad Jamil, DE 210004. So I will present to you about the lab view of project. So you see here is a front panel we designed using a lab view. Think of this user interface of control panel for our system. So where we can see information and control what's happening. Next is lab view is a special software that let us build and control system using a picture, not just a text code. So it's like a building with a Lego block, but for software, this make it easier to see how everything connect and work together. Next is this specific design is set up to detect a leak of an abnormal signal. So imagine that we are monitoring a system like water pressure or temperature. We want to know if it goes above a certain level. So on the left, we have a graph called signal over time, which is this graph shows the real-time data we are monitoring. We can see how the signal change over a period. And then on the right, we have our control and indicator, which is this like a switch and light on our control panel. So stop button that lets us turn the system on or off. So and then we have simulated signal where we can input or see the current value of our signal. And then leak threshold is the critical level. We are watching that if our signal goes above this, so it's a problem. And then the leak detected, which is this is our alarm. If the signal goes above the threshold, this light will turn on. So in example, the simulated signal is at 3 and our leak threshold is 3.5. Since 3 is less than 3.5, the leak detected light is off. So this shows the system is currently normal. If the simulated signal were to go to then if the simulated signal go to, then the leak detected light will turn green and then alerting us to a problem. So next we go to the block diagram of the lab view. So this is the block diagram, is the actual program, and the wiring behind that what you saw in the previous screen, the front panel. So in the lab view, we connect different function block with the wires to create our program. So on the left, we have our simulated signal and leak threshold input. These are the same input you saw on the front panel. Data from this control flow into our program. The orange wire connects this to a greater than function. This triangle symbol, the line, is a logical comparison. It checks is the simulated signal greater than the leak threshold. The result of the comparison, true or false, then go to the leak detected. If the signal is greater than the threshold, the leak detected light on the front panel turns on. If it's not or false, the light stays off. They point to the leak detected block. So the signal over time graph also gets its data from the simulated signal and let the visualize it. Then this block simply takes the data and display on the graph you saw before, and the entire program run continuously inside a while loop. So this larger border around everything means the system keep checking the signal over and over again. So in real time, until we press the stop button, the 1000 and the clock icon indicate a delay 1000 millisecond. Same goes to 1 second, meaning it's update every second. That's all. Alright, so next is the tools that we use in the LabVIEW program. So first is round LED. This is like a simple light bulb on our control panel. It turns on or off to show us a true false condition or status in our leak detector. It lights up when a leak is detected. Next is numeric control. This is a box where we can type in a number or just input arrows. So it allows the user to input the numerical values into the program. So example is where we set the simulated signal and the leak threshold. Next is the waveform chart. This is a graph that displays the data over time and show how a signal measurement changes as time passes, like a moving line on the screen. So in our example is the signal over time graph. Next is the stop button, which is a simple button, usually red that you click, and it tells the LabVIEW program to stop running. It's clean away to end your program execution. So while loop, this is a program structure that looks like a box with an arrow going back on itself. It makes a section of your program run over and over again continuously until a specific condition is met. So it's essential for real-time monitoring and control. Last but not least is logic. This is a comparison function, especially one that check if one value is less than or another. So it compares two numbers and give a true or false answer. If the first number is indeed less than the second, it outputs true, otherwise the false. So is more to decision making in our program, like checking if a temperature is too high, if a tank is full, or if a signal has crossed the threshold. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FAIZ and ABIDIN. My metric number is DE21004. So today I will be presenting or demo about our project, which is the simulation. So this one is the leak detection of the block diagram. So this is while loop. So we want to loop the condition must be in a loop, so we can run the program, and then the leak threshold is we set at 3.5, and then simulated signal, which is our design input, we will input it later, so I will show you later. And then this one is the less logic. So if the leak threshold is, if the simulated signal is less than the leak threshold, the leak will not detect. This is the LED, so it will turn on if the simulated signal is above threshold. So for the signal over time, we'll display the simulated signal because you can see the connection here. So we can see the graph, and then this one is the time interval. The time is just to construct the while loop. So while loop will be running for 1 second, and then this is the stop button, which is the stop command. After 1 second, the while loop will stop. So we need to put it here, or the code will run forever. And if we don't put the stop, the code cannot execute. It needs a stop command. So we're moving on to the front panel. So front panel, this is a signal over time just now. This one is stop. Stop doesn't really do anything. and then this is the leak detected, and this is the simulated signal, which is our input, and this is leak threshold. So if we put the, let's say 2.5, so 2.5, the gas leak is 2.5, so the leak threshold, if I run, so it will become here 2.5. You can see at the graph. And then the leak detected, no, because it is below threshold. So let's say I put it 3.8, and then I run. So yes, the signal over time will go to the 3.8, and then the leak will be detected. So I think that is the focus for our simulation, for our project, just to detect the gas leak by using this simulation. And this is the rough idea and prototype of our project. So I think that's all from me. Thank you very much.